Hello children, welcome to digital classes. Children, in today's class we are going to continue with our lesson of electrical conductivity in liquids. Children, I hope you have gone through your textbook and understood the previous content very well. So children, first let us see what we have learned in the previous session. In the previous session, we had learned about materials that allow electricity to pass through them are called good conductors of electricity. For example, we have iron, nickel, copper, such things allow electricity to pass through them. And then we have seen materials that do not allow electricity to pass through them are called as bad conductors of electricity, like plastic, paper, rubber and wood. Then we have also seen that if the material has high electrical conductivity, then it is a good conductor of electricity. Electrical conductivity is a nature or a phenomena present in all the substances. Higher the electrical conductivity, the more good conductor it becomes. Some liquids are good conductors of electricity. So children, in the previous session we have seen an activity to see which liquids are good conductors and which liquids are bad conductors. Water in its pure form is a bad conductor of electricity. So children, what is pure water called as? Yes, pure water is called as distilled water. So this distilled water is a poor conductor or a bad conductor of electricity. And we have also seen that when pure water is dissolved with salts, acids or bases, it becomes a good conductor of electricity. Children, this also we have seen through an activity in which we have taken distilled water and solutions of distilled water with lemon, with vinegar and with salt and copper sulfate. Then children, we understood that most liquids that are good conductors of electricity are solutions of acids, bases or salts. So children, this was what we have learned in our previous session. Now let us see what we are going to see in today's class. Children, in today's session we are going to learn about the chemical effects of electric current. That means what may happen if current passes through certain substances. Then we will try to understand what an electrolytic cell is and how we can make our own electrolytic cell. Then we are going to see the definition of electrodes and electrolyte. We are going to understand the concept of electroplating. Then we will see a small activity on electroplating, that is how electroplating is done. And then uses of electroplating. These are the topics that we are going to learn today, children. So now let us begin with what we are going to start today is chemical effects of electric current. So children, what do we want to understand when we are saying chemical effects of electric current? When electric current passes through a substance, a chemical reaction takes place in the substance. So whenever current passes through a substance, then there is a chemical reaction that brings about some changes in the substance. Okay children, that is what we are saying is chemical effects of electric current. So for example, when electric current is passed through water, it gets dissociated into hydrogen and water. Now children, water is a molecule that is composed of hydrogen and oxygen atoms. Its chemical formula we know is H2O. Okay children, H2O is the chemical formula of water. So when current is passed through this water, then the electric current makes the water molecules to get dissociated as hydrogen and oxygen. When electric current is passed through a solution, then the solution of the color may also change. So this is another example, children. When current is passed through a solution, a colored solution, then the color of the solution may also change. This is two examples of chemical effects of electric current. Children, what do you see on the screen? The effect of electric current on a potato. This is what we are going to see. Okay children? So this must be a very familiar activity to you children. We have a half cut potato, we are going to connect it to a battery, and then there will be a measurement, a device to measure current or a bulb, right children? So that it will show a reading. This is a device measuring current which will show a reading. So for this, what are the steps we have to do? Take a half cut potato, construct a tester with LED bulb and insert the two ends of the copper wire into the potato with some gap and record your observation. Children, now let us see this activity. Yes children, for this we need a battery, some connecting wires, an LED bulb and a half cut potato. So we are going to insert the ends of the copper wire into the potato. Okay children? In this way. Instantaneously you will observe that the bulb starts glowing. Yes children. So what is so new in this? You must have done this in your previous classes itself, that when you insert a tester in the potato, then the bulb will glow, the LED will glow. But children, here we are not just looking at the bulb glowing. We have to see for something else, that is, when current is passing through the potato, what is the change that we are observing? Current is flowing children. Current is flowing through the two terminals. The red color wire is the positive wire and the black color is the negative. Now children, observe the end with the positive connected wire. What do you see children? Yes, that has colored. The color has changed to greenish blue near the wire with the positive terminal. Yes or no children? Did you observe the color? So here electrons are flowing from negative terminal to the positive terminal, right children? So because of flow of electrons, it is turning into bluish green color. So children, what did you observe? So first we observed that the bulb has glowed. Did the bulb glow? Yes. What changes did you notice in the potato after some time? We noticed that end that is connected to the positive terminal has turned into bluish green color. Why did this happen? Okay children, we are going to explain this in detail. This happens because of the flow of electrons near the positive terminal. Now children, it is a very simple activity which you also can try at home. You can also try this with sweet potato, brinjal, tomatoes and many other vegetables. Right children? Now children, we are going to learn about a great scientist called Alessandro Volta. Alessandro Volta discovered that it is possible to generate electricity if two different metals are placed in the same liquid. So children, previously people used to think about or they used to search about a permanent solution which can give a continuous current supply. Okay children, they were looking at different mechanisms or different products that can give a continuous current. So then children, Alessandro Volta came up with a very genius idea. He proposed the electrolytic cell. So Alessandro Volta discovered that it is possible to generate electricity if two different metals are placed in the same liquid. Okay children, so it was Alessandro Volta who discovered that if you keep two metals in a electrolytic solution or one liquid which can pass electricity to it, the condition is that it should be a good conductor, then electricity can be generated. This is the voltaic cell children. This is called as a Volta cell after Alessandro Volta, or it is also called as the voltaic cell. So this was first made in 1800 by Alessandro Volta. He used zinc and copper plates. See here children, zinc and copper plates, and he dipped them in diluted sulfuric acid. Okay children, they were dipped in diluted sulfuric acid. This cell is named as Volta cell after him. So the name is given as Volta cell or voltaic cell after Alessandro Volta because he discovered it. And the word voltage that we use in our everyday life, okay children, that is the batteries are also named as 22 volts or 1.5 volts, 3 volts, right? So the voltage name is also given because of Alessandro Volta. So this Volta cell called as the electrolytic cell was discovered by Alessandro Volta. So children, let us see what we need to make an electrolytic cell. We need 2 injection bottles or disposable glasses, 5 to 10 centimeter long copper and zinc strips, connecting wires and an LED. So here children, we have taken 2 injection bottles, have taken a copper strip and joined it to one end of the LED, and in the other bottle the zinc plate is joined to the other end of the LED. Okay children, and the zinc in this bottle and the copper in this bottle are interconnected, right children? Now when the connection is made, you will see that the bulb starts glowing. In case the bulb doesn't glow, children, just try to exchange the terminals of the bulb. Okay children, you will observe that bulb starts glowing in this. Now we will try to understand how this is possible. When we immerse the copper and zinc plates in sulfuric acid, then zinc starts dissolving in the acid. Children, this can be observed by the bubbles forming on the zinc plate as soon as you dip it in the acid. Immediately you will observe that zinc starts to dissolve in the acid. Small bubbles are observed near the copper strip. Now even near the copper strip, small bubbles are observed. That is, current flows from copper plate to the zinc plate. So actually what is happening here children, when zinc is dissolving in this acid, electrons are getting dissociated. It is getting converted into zinc ion. These electrons are moving towards the copper plate and thus current is flowing from copper to zinc plate. These plates or rods are called electrodes. So the terminals, the copper terminal and the zinc terminal here are called as the electrodes, and the dilute sulfuric acid used in this is called as the electrolyte. So the 2 metal plates or rods that are used in the electrolytic cell are called as electrodes. They act as the terminals of a battery. Now children, we know that the battery has a positive terminal and a negative terminal. So the electrodes also act as a positive terminal and a negative terminal of a battery. The liquid used in the electrolytic cell is called an electrolyte. Right children? The liquid that is used in the electrolytic cell is called an electrolyte. This acts as the chemical used in the dry cells. If you have a battery children, after it expires, you can just cut it open and see it contains some chemical. So the electrolyte acts as the chemical that is used in the dry cells. Now children, let us look at some images before going into our next topic. What do you see here children? These are the external parts of a motorbike. Yes children, these are some shining articles. Okay children, this is a gold medal probably, and this is a trophy. Right children, trophy that can be awarded, and medals you must have won in your school days. Okay children, now our question is, why are these objects so shining? Why do they shine so much? How do they shine so much? Okay, and does the shine remain forever? Did you ever see such things children, that when you bought them or when you first saw them, they were shining very brilliantly, but later on something happened and the shine is lost? Did you ever see them children? You must have seen. What happens if you deliberately try to scratch the surface? Now if you have any of these things at your home, or even a small safety pin children, if you have a brand new safety pin, try to scratch it. If you try to scratch it, you will see the upper cover coming off. Okay children. What we see is a presence of another metal below it. So the upper cover is shining, but inside there is some other material which is not very attractive or very shiny. The surface metal was coated to protect the inner metal. So the metal on the surface it is another metal which is coated on the inner metal to protect the inner metal. Okay children. This phenomena or this process is called as electroplating. Now let us see what is electroplating children. To understand about electroplating, we need copper plate, crystals of copper sulfate, a key made of iron, glass beaker, water, sulfuric acid, battery and some connecting wires. We are going to coat an iron key with copper by electroplating method. So children, let us see this video. For this activity, we need a battery, a switch, some connecting wires, a key, copper sulfate crystals and a glass of water. We also need a copper plate. Children, let us see how we are going to connect it. We have given the connections here children. The positive is connected to one end of the switch. The negative is connected to the key with the help of a conducting wire. The other end of the switch is connected to the copper plate. Okay children. Now this is a solution of copper sulfate ready children. Crystals dissolved in water. We are going to immerse the copper plate and the key in the copper sulfate solution. And switch the circuit on. Children, here we are going to observe some bubbles formed near the key. You will see that bubbles are formed near the key. Observe closely children. You can see bubbles coming out from the key. Isn't it children? Yes. That means some chemical reaction is taking there at the key. Now let us remove the key and observe what are the changes. So children, the key has turned into a dark color and observe the tip of the key children. It has turned into a golden brown color. Are you able to see it children? Yes. So the key has turned into golden brown and there is a change in the color. This is also one of the effects of chemical electric current. Children, I hope you understood the activity of electroplating. Now, let us see some precautions. Rub the ends of the connecting wires with sandpaper before giving the connections. So, before giving the connections, we have to rub the ends of the copper wire with sandpaper in order to remove any oxidation from it. Care should be taken that the key and plate do not touch each other. In this activity, the key and the plate should not be touching each other. We saw that the key turns into light brown color and this color is due to the deposition of copper ions on the key. So, what is happening children? The copper ions in the solution are getting attracted towards the key and the key is turning into light brown color, that is copperish color. So, let us understand now why does it happen. Copper sulfate solution contains copper ions and sulfate ions. When electricity is passed through this solution, the free copper ions are drawn towards the negative terminal. So, when current is passed through this electrolytic solution, the free copper ions in the solution are drawn towards the negative terminal. The copper ions get deposited on the key as it is connected to the negative terminal. Now, the copper ions being positively charged, they are getting connected, they are getting attracted towards the negative terminal, that is the key. One material gets coated with another due to electricity. This is called as electroplating. So, because of presence of electric current in the liquid, one metal is getting coated or plated onto another metal. This phenomena is called as electroplating. So, children, definitely this must be having some great uses. Already we have seen a few. So, let us try to understand the uses of electroplating. Before that, we will see the conditions for fine coating. The object to be electroplated should be free from greasy matter. That means the key that we have used here, it should not be having any grease particles on it. The surface of the article should be rough, so that the metal deposited should stick on it. That is, it should not be a very smooth surface, children, it has to be a little bit rough surface. The concentration of the electrolyte should be adjusted to get a smooth coating. In order to get good coating, a smooth coating, we have to adjust the concentration of the electrolyte, that is, the amount of sulfuric acid used should be changed accordingly. Current must be the same throughout. Now, coming to uses of electroplating. This concept or this process of electroplating is used in industries for coating metal objects with a thin layer of different metals. So, mostly this is used in the industries for their machinery parts as well as in the automobile industry. So, where the use of metals like iron is more. But children, iron, you know, it is prone to corrosion. Yes or no? It will get corroded easily. That means rust formation. Yes, iron forms rust very easily. So, in order to avoid rust formation, metals like iron are coated with other metals like chromium or nickel to protect from corrosion. So, this nickel or chromium is coated on iron. This is chromium plated, children. So, chromium does not get rusted, does not react with the atmosphere, but iron reacts very fast. So, chromium is plated, electroplated on iron to protect it from corroding. It is used in ornamentation and decoration. Articles made of copper and its alloys are coated with gold or silver. Children, you must have heard rolled gold, or you must have heard imitation jewelry, or you must have heard things like gold plated jewelry. So, children, here copper material is also prone to oxidation, even it changes its color very easily. So, this copper is protected by plating with gold or silver, and these are used in ornamentation or decoration purposes. Processed food items are stored in tin coated iron cans. So, children, we know that in many countries food is stored in cans. Yes, children, in cold countries food is stored in cans. These cans are tin coated, children. Tin is also a metal, but tin is not a reactive metal like iron. So, iron cans are coated with tin and the food is stored in these tin coated cans. Right, children? Directly iron cans, they get oxidized easily and the food may get spoiled easily. But tin coated cans, the food will be preserved for a long time. Tin is less reactive to food than iron. So, food cans are made by electroplating tin on iron. Iron coated with zinc protects it from getting corroded and formation of rust. So, once again, children, you can see here the nuts and bolts, heavy machinery objects, all these pipes, they are zinc coated, children. Yes, they are zinc coated. So, iron material they are made up of iron, yes, very well, but they are coated with zinc so that it does not get corroded easily. What happens, children? We are trusting iron, yes or no? We are trusting iron to build strong buildings and bridges. But what if it gets corroded? If rust forms, then it may break easily. So, in order to avoid this corrosion, we are coating iron with zinc. Children, we have come to the end of this session. So, let us see what we have learned in today's session. Vegetables and fruits contain certain types of acids because of which current passes through them. Alessandro Volta designed the first electrolytic cell using copper and zinc rods dipped in sulfuric acid. The rods used in the electrolytic cell are called electrodes. The acidic solution used in the electrolytic cell is called an electrolyte. Chemical energy gets converted into electrical energy by the process called electrolysis. The process of coating one material onto the surface of another is called electroplating. Electroplating is done to protect the inner material from getting corroded. This is used in industrial machinery parts, automobile parts, ornaments, decoration and to store processed food. Try to answer the questions given here. Give some examples of electrolytes. Electrolytes, children, we have used in the voltaic cell. What did we use there, children? We have used the diluted sulfuric acid. Yes. So, in the similar way, can you try to name some more electrolytes? Yes, children, you can do it. Please try. Draw the diagram of electrolytic cell and explain. Children, this diagram is given in your textbook. You have to read the activity and draw the diagram, label the parts neatly and try to explain the voltaic cell in detail. The third question, children, which energy is caused for glowing of bulb in the electrolytic cell? Yes, children, very important thing. What is the energy which causes the bulb to glow in the electrolytic cell? The Volta cell that we have seen, children, which energy is causing the bulb to glow there? That we have to mention. The last question is higher order thinking question, children. In the electroplating activity, if the key is to be coated with aluminium, what changes do we need to make in the experiment? So, here, children, I will give you a small hint. We have made use of copper so that the key has to be coated with copper, and we took copper sulfate crystals. Yes, children. So, here the metal and the electrolytic solution are the same. This is a small hint for you, children. Based on this, you can answer this question very well. Okay, children, I hope you have understood this session very well. So, keep learning and try to solve the worksheets provided by SIET also. Bye, children. Happy learning.